Good evening to all of you. Welcome you guys. Welcome you all. I think we are live. Yeah, first of all, do comment करके बोलिए is the audio videos clear to everybody? जल्दी से जल्द comment करके बोलिए now. Yeah, the great news to the all the 2027 2028 का aspirants को बढ़िया खबर आई. Now, if your dream is to enter into IITs or PSUs, this is one golden opportunity to all the aspirants. Now you can get this Unacademy subscription that is just 9,999 only for 2027-2028 के लिए. So you'll get up to 60% of flat discount आपको मिलेगा पर IITs या PSUs में enter करने के लिए. So जल्दी से जल्द शुरू करो आपका preparations and you can use the yes, this offer is applicable up to the March 14th only. And so you can use the my personal code. You can see the personal code that is BV Reddy. Use the code of BV Reddy and do join in our plus courses to have a great learning experience from the top educators. And so get rank predictor of Unacademy which is live. You can check your rank. And here you can simply copy the response sheet and you can paste it. Then you can able to predict your rank immediately. Yes. And we started the new batches we have started. You can have a look at now. From March 13th onwards, नया batch शुरू होने वाला. So for 2027 के लिए, so analog electronics is going to start. And so this is for 2028 के लिए. So that is starting from 7/13 and you can find the top educators team आपको एक साथ मिलेगा. So these are the ESC 2025 rankers. ESC 2025 rankers from Unacademy. Now this is the starter kit for GATE 2027-2028 के लिए आपको मिलेगा. And this the meet your new friend Unacademy Una. So this friend will help you to clear all your doubts. And there are 3 modes are there. You can see voice mode and quiz mode and smart summaries. You can talk to Una and you can communicate with Una according to requirements. And the test series available. So we do offer the 2 subscription plus wala as well as iconic subscriptions. And plus में आपको क्या चीज मिलेगा? The top educators classes, live doubts cleared होगा, core test series and structured courses PDF, live test, unlimited access. And iconic में आपको क्या चीज मिलेगा? Personal coach मिलेगा and physical notes भी आपको मिलेगा. So you can book your slot according to time convenience and you can communicate with your mentor. These are the GATE 2025 rankers. चलिए आज का सेशन हम शुरू करेगा. In this session we are going to discuss the most expected questions for the BARC exam questions हम discuss करने वाला. ठीक है? So take the first problem. A coil of 200 turns and area given 0.2 meters square is rotated at at a half a revolution per second is placed in uniform magnetic field of B value given perpendicular to the axis of rotation coil. The maximum voltage. Yeah, what is the EMF induced in this coil? You tell me now here. The induced EMF. And this is what type of EMF will call, you tell me now here. Rotational EMF. The rotational EMF is given as NBA omega into sine theta. Rotational EMF. So they are asking the maximum value. So simply we can find the peak value. That is what, tell me now, NBA omega. Right. So this number of turns is given now. How many? 200 turns are given. B value how much? 10 power minus 2. Area given now. So that is 2 into 10 power minus 1. And this omega. How much is omega? So this is which is equal to 2 pi f. F is given as what element of 1 by 2. Yeah, which will be equal to what element of pi. This is pi. Yeah, you can simplify it now. So the 10 power minus 2, this thing will get cancelled. So what will come, you tell me now here, which will be equal to 4 pi by 10. So it will be equal to what we can say now, 2 pi by 5 is the EMF peak value. Next, a coil is placed perpendicular to a magnetic field of 5000 turns when the field is changed to 300 turns in 2 seconds. An induced EMF of 22 volts is produced in the coil. If the diameter of the coil is 0.02 meters, then the number of turns in the coil is, yeah, you can see now a coil is placed in a magnetic field of this much. So we have initially we have this magnetic field. If I say B1, B1 is how much they given now? We have 5000 Tesla they given. When changed to this much, B2 value given as how much? 3000. In 2 seconds, the time is given as what element? 2 seconds. So magnetic field is changing. So they given the EMF induced is given. Here the time varying magnetic field which is given as 22 volts. The diameter is given, so we can find the radius is equal to, I can say 10 power minus 2 meters. The number of turns we need to calculate now. N value we need to calculate. Yeah, you can tell me now. So the EMF in a coil which will be equal to what you tell me now here. So this is N into here. Yeah, so radius A value constant, so only the B value changes, dB by dt. So you can simplify now, put the data, N value, number of turns, yeah, we need to calculate. So this value 22 given, N is N into, I can say pi R square, that is 10 power minus 4 into dB by dt. So that is equal to 2000. So we can say now 2000 by t. T value how much now? 2. Yeah, simplify करके बोलिए ना उधर. So this value which will be 1000 na? And so this we can say this is 22 which is equal to N into pi 22 by 7 and this is 10 power minus 1. So this 22 will get cancelled. So this N is equal to how much now? Cross multiply will come to be a 70. Check it all of you. Next. The magnetic flux linked with a closed circuit of resistance 8 ohms varies with the time is given as like this. The magnetic flux is given, they ask him to find the induced current. Phi value given as what element of 5t square minus 36t plus 1 given. This is the flux. Then what will be the EMF, you tell me? And which will be equal to minus of d phi by dt, right? Which will be equal to minus of, tell me now here, 10t minus what element of 36, and they given the t value mentioned now, which will be equal to 2 seconds. So we can get this EMF value, which will be equal to minus of 10 into 2, 20 minus 36. Yeah, which will be equal to what element of minus or minus plus 16 volts. Now we need to calculate what element of here. Induced current we need to calculate now. This I is equal to what you can see now here. So that is EMF by resistance. So this I value, which will be a 16 by 8 ohms, which will be equal to 2 amperes. Next, a square loop of side 10 centimeters and resistance 0.7 is placed vertically in east-west plane. East-west plane. Okay. East-west plane they has placed. Okay. Now what they are saying here, a uniform magnetic field of 0.2 Tesla is set up across the plane in northeast directions. Right. So we have the plane. This is located in the like this. And here this is a plane. Right. And they given this as magnetic field is what direction? So magnetic field. So generally which we should take positive x-axis, and this is the positive x-axis will be taken as what tell me now? East directions. And this vertically y-axis will be taken as north directions. They given this field, magnetic field is what direction they given, you tell me now here? Northeast, like this now. The northeast they given, and they given this. So this angle is something 45 degrees now middle. Here is a magnetic fields. So we can say now theta, this theta is 45 degrees. And so we need to find the flux. So induced EMF basically which will be given as what, tell me now? That is minus of d phi by dt. And what will be the phi value here? Flux is equal to B bar dot A bar, which will be equal to BA cos theta. BA cos theta. So the flux will come to be a BA cos theta. B value is what, tell me now? 0.2 into A value, area, square loop now. So this value 10 into 10. So this is 100 into 10 power minus 4 into cos 45, that is 1 by root 2. So how much will come this flux value? This value 2. So I can write this as what, tell me now here? This is So 0.2. So this value will come to be a root 2 into, and this value 10. So this value 10 power minus 3. This is the flux. And we need to find the EMF. Tell me now. So the EMF, which will be given as, which will be equal to change in flux. So this is minus of root 2 into 10 power minus 3 by, in what time they given now? 1 second. So that is EMF. It should be equal to root 2 into magnitude is 10 power minus 3 volt. Next, a rectangular loop of length is given 2.5 meters. Width is 2 meters. Placed at 60 degrees to a magnetic field. Okay. The loop is removed from the field in 10 seconds. The average EMF is. Okay. Rectangle loop is placed like that. Now, first of all, we can find the flux. Now, flux is equal to, I can say now, BA cos theta. Right. So, B value, how much now? 4 into A value, that is 2.5 into 2 into cos 60, that is 1 by 2. So, this 2 will get cancelled. So, how much is flux value? Tell me now here, 10. And so they ask him to find the EMF now. So that should be given as what? Tell me now. Minus of d phi by dt. It should be equal to what? Tell me now here. 10 by 10. Right. Okay. Initially, so this is the flux we have. I can call this flux is phi 1. Next, it is when it is removed, flux will be 0. Isn't it? When it is removed from the loop, how much the flux now? Which is 0. There is no magnetic field now. So that means EMF, which will be given as minus of d phi by dt, and which will be equal to minus of what we have. Tell me now. Phi 2 minus phi 1 by T2 minus T1. So then which will be phi 2 value, that is minus of 0 minus 10 by T2 minus T1, which will be a 10 seconds, and will come to be a EMF that will be equal to what? Tell me now here. So plus 1 volt. Next, an insulated copper wire of 100 turns is wrapped around a wooden cylindrical core of cross-sectional area 24 centimeters squared. The two ends of the wire are connected to a resistor. The total resistance in the circuit is 12 ohms. If an externally applied uniform magnetic field in the core along its axis changes from 1.5 Tesla in one direction to 1.5 Tesla in opposite direction, the charge flowing through a point in the circuit during the change of magnetic flux is. Right. So you can see now they ask him to find the charge. Basically, how we'll get the charge will be given as, that is integral of I into dt. So what is this thing I value given as? What is this I now here? So I is equal to, that is EMF by resistance. I is equal to EMF by resistance. And what about this EMF? Tell me now. That is 1 by R into what we have. Tell me now. D phi by dt only now. This is I. So from this Q value will come to be a integral of I means what? Tell me now here. D phi by R into dt into dt. So this will be get cancelled. So then what I will get, to tell me now. So this Q value, which will come to be a 1 by R integral of d phi. So this means Q is equal to, that I can say this as delta phi by R. So that means induced charge, which will be equal to what, tell me now, delta phi by R. So we can use and calculate now. So this is Q, that should be equal to, since we have minus is there now, this minus minus. So because of this minus, I can say this as phi 1 minus phi 2 by R. So you can tell me the phi 1 value, phi 2 value. Phi 1, which will be equal to, yes, so that is NBA. Okay, so let us say B1. And this phi 2, yes, so this phi 2 value, which will be equal to minus NB2A. So this change in flux, which will be equal to 2NBA by R. Yeah, you can tell me now, substitute the values now here. So this value Q, which is equal to 2 into N value 100 and B value 1.5 and A value 24. So this is 24 into 10 power minus 4 by R 12. So you can simplify it now. So this is 12 twos now. So how much I will get now here? So this value 3, 6. Yeah, 6 into 10 power minus 2. So then it will come to be, I can say, 60 millicoulombs. Next one. A conducting circular loop is placed in a uniform magnetic field of 0.4 Tesla with its plane perpendicular to the field. Somehow the radius of the loop start expanding at a constant rate of 1 mm per second. The radius is changing. The magnitude of induced EMF, they ask him to find. So what is the EMF, you tell me now here, which will be area changes, B value constant, so I can write it as dA by dt. A number of turns are 1. So you can tell me now from this EMF, so B value given as 0.4 and this is d by dt of area, means what I can say now, that is pi r square. So that is 0.4 into differentiation 2 pi r into what we can have, tell me now, dr by dt. So that is EMF, which will be equal to 0.4 into, that is 2 pi r. So how much the radius we have? 2 into 10 power minus 2 dr by dt, that is 10 power minus 3. So we have EMF that should be equal to how much now? 10 power minus 5, 6. So this value 4 into 4, 16. 16 pi. 16 pi into 10 power minus 6. How much this value 16 pi means? So this 16 pi. So this value 50. So this is 50, no, microvolts. Next, and you see the magnetic field B crossing normally a square metallic plate area 4 meters square is changing with the time as shown in figure. The magnitude of the induced EMF is, now you see this thing here, basically the EMF which will be equal to what, tell me now? So this is A into what I can say, tell me now, dB by dt, isn't it? A into dB by dt. Okay. Now, so dB by dt is nothing but slope only. So tell me how much the slope of this line, that is 2 by 1. Area, that is how much now? 4. Slope is what, tell me now? 2 by 1, that is 2 into 10 power minus 3. So it will come to be 8 millivolts. Next. The induced EMF can be produced in a coil by, how we can get the induced EMF? Moving the coil with uniform speed inside the magnetic field. With uniform speed nahi chalega. Moving the coil with a non-uniform speed inside a uniform magnetic field, no. Rotating the coil inside with the uniform, yes, rotational will causes. Rotating the coil. Okay. Changing the area of the coil inside the uniform magnetic field. Yes. So that is C and D are correct. Next, a coil is placed in a magnetic field such that the plane of the coil is perpendicular to the direction of magnetic field. The magnetic flux to the coil can be changed. How we can change the magnetic flux? Tell me. The magnetic flux basically which is given as what, tell me now, NBA into cos theta. So on by changing what, tell me, changing the magnitude of magnetic field. Yes, B changing will changes. Area, yes, area changes also changes. Angle changes also changes. By reversing the magnetic field direction abruptly without changing the magnitude. No, A, B, C are correct. So option D. B value same means no change of EMF we have, but flux value magnitude remains same only na. A square shaped coil of 70 centimeters square having turns given rotates in a magnetic field of about an axis which is parallel to one of its side of coil along perpendicular to direction of the field. If the coil completes 400 revolutions in a minute, the instantaneous EMF when the plane of the coil, yes, now this is the plane of a coil if I call, which will makes what, tell me now? Plane of the coil makes an angle of 60 degrees with the field. This is the magnetic field. They given this is 60 degrees is given and this is the area vector. We need the angle means always angle between B and A. So how much this A value, tell me, should be taken? Theta value which will be a 30 degrees. This is one crucial point. Angle in the flux, angle between B and A we should consider. Yes, you can tell me now here. Yes, so this EMF which will be equal to NBA omega into what, tell me now, sine theta. So this will be equal to N value 600, B value how much now? 4 into 10 power minus 1, A value 70 into 10 power minus 4, omega value 400 400 revolutions per minute into 2 pi by 60, yes, into sine 30 value 1 by 2. Yeah, tell me now, simplify here. So 60, this is tens na, right? So this two get cancelled. So you can see now what are the terms left out now. This I will cancel. Now we have, so this is 5 into 4, 22. So I will cancel 0, 0, this, yes, 20, this 4 will get cancelled. 2 into 4, 2 into 7. So here 14, pi left, keval. Check karo. That is 14 into 22 by 7. So 2 is now 44. Check this value. Next, a rod with circular cross section area 2 centimeters square and length 40 centimeters is wound uniformly with 400 turns of an insulated wire. If a current of 0.4 amperes flows in the wire windings, the total magnetic flux produced inside the windings is this much. Relative permeability is, permeability they ask him to find. So the magnetic flux phi is equal to what we can say now, B into A now. And there's a rod with circular cross section, so along the length. This is nothing but in the form of solenoid only. So B is equal to what, tell me now here, mu N I by L, where mu is given as what, tell me now, mu R into mu naught into N I by L only. So this A is equal to pi r. Area given, yes. So this phi value will come to be A. So this is mu r, mu naught. So this is N I by L into A. So you can simplify now here. This is mu r into mu naught is 4 pi into 10 power minus 7. Number of turns is given 400 into I value given 4 into 10 power minus 1. Yes, A value is area. So that is 2 into 10 power minus 4 by L. Length is what, tell me? 40 into 10 power minus 2. So you can simplify now 40. This value tens. Yes, will get cancelled. Okay. Oh, here the given flux is given. Okay, so from this, what will come here? This is 4 pi into 10 power minus 6 given. Mu r value we should calculate. And here we have 4 pi into, this is 4 into 2, that is 8 into 10 power minus 11 plus 2. So you can see now this 4 pi will get cancelled. So then it is mu r equal to what, tell me now, 10 power. Here minus 6 by 10 power minus 8. Yes, 1 by 8 also. Then will come to be a mu r value. How much now? This is 100 now. 100 by 8. Isn't it? Check करके बोलिए calculations. So this value 11. This is 9 now. This is 9. Yes, this is the BARC PYQs only. Right. Yeah. 10 power minus 9. Yes. So that means one more 0 will come now here. So then what will come here? 4 2s, 4 250. Then it will be equal to 125. So this mu r value 125. Check it all of you. Next. A certain elastic conducting material is stretched into a circular loop. It is placed with its plane perpendicular to uniform magnetic field. When released, the radius of the loop starts shrinking at a constant rate of 2 centimeters per second. The induced EMF in the loop at any instant when the radius of the loop is 10 centimeters. Okay, so what is the EMF? Tell me now, basically, which will be equal to, yeah, B into minus B into dA by dt. Here the A value changes now, so that's why. So the EMF, it should be equal to minus B, that is 0.8 into what we have tell me now, d by dt of what tell me now, pi r square. So then it will come to be a minus 0.8 into this is 2 pi r into dr by dt. So this value minus 1.6 pi into r. How much is radius you tell me now? 10 centimeters. 10 into 10 power minus 2 dr by dt, that is 2 into 10 power minus 2. Yeah, simplify and get it. So this EMF, which will be equal to what, tell me? Yeah, 16 pi, 32 pi we can write into 2 na. So this is 32 pi into 10 power minus 4. So this value 3.2 pi millivolts. Next. A conducting loop of radius is given is placed perpendicular to uniform magnetic field of 0.5 Tesla. The magnetic field is decreased to 0 in this much time. The induced EMF is, yeah, so they given this initially the magnetic field B1 value given as 0.5 given, right? Now thereafter it is decreased to 0. B2 value 0. So I can say this as phi 1 equal to, we can say now BA cos theta, that is BA. So will come to be a phi 1 value, B value, that is 1 by 2, that is pi r square. R is 10 by root pi ka whole square. So then this phi 1 value will come to be 100 by 2, that is 50. So then phi 2 will come to be a 0. So what will be the EMF, you tell me now, which is equal to minus of d phi by dt. So then it is EMF that should be equal to, for minus that minus of final flux is 0, initial flux is 50 by this time is given now. Is to 0 in 0.5 seconds. So this value will come to be a 50 by, okay, this radius, that is 10 power minus 4. This is into 10 power minus 4 into 10 power minus 4. Then this EMF, which will come to be a, what, tell me now, 100 into 10 power minus 4, which is equal to 10 power minus 2, which will be equal to 10 millivolts. EMF. Next, a conducting circular loop is in XY plane. Okay, loop is in XY plane. So this means, what is this area vector, which will be a into XY plane, unit vector is K cap na Z directions. And D value given us, what, tell me, 3T square into J cap plus 3T square into K cap. So this flux, which will be equal to, what we can say now, B bar dot A bar. So this flux will come to be a B bar dot A. Here A means pi r square, we can write now. That is pi into K cap. R value 1. So will come to be a K dot K, which is 1. So that is 3 pi T square. So this EMF, which will be equal to, we can have, this is d phi by dt. So this EMF, which will be equal to, so this is d by dt of phi is equal to 3 pi into t square. So it will come to be a 6 pi t, t value 2 seconds, that is 12 pi. Of course, we are talking about the magnitude. Okay. Okay, fine. Yeah, that's it for today's session. So we will meet in the next class. We'll continue next remaining problems. Okay, then see you. Bye bye. Good night.